This movie covers subtopic 6.1, Introduction to the Atmosphere, under the main IB ESS Topic 6, Atmospheric Systems and Society. Significant idea number 1 for this subtopic is the atmosphere is a dynamic system which is essential to life on Earth. Has the atmosphere always been as we know it today? No. When Earth was formed, its atmosphere was likely composed of mostly hydrogen and helium. This atmosphere, however, didn't last very long because the solar wind from the sun blew it away. Solar wind is a stream of charged particles such as electrons, protons, and alpha particles. We now have a magnetic field surrounding Earth that shields us from solar wind. The second atmosphere formed a little over 4.5 million years ago and was produced due to volcanic outgassing. Outgassing is the release of gas that was trapped in some other material. In this case, volcanic outgassing released hot gases trapped deep within the interior of the planet. Water vapor, carbon dioxide, and methane. Ammonia and other gases similar to ones produced by volcanoes today were expelled. Over millions of years, the Earth gradually cooled. When the temperature dropped enough, water vapor condensed and went from a gas to liquid form. This created clouds. From these clouds, oceans formed, and the oceans absorbed a lot of the carbon dioxide in the atmosphere. A small amount of oxygen was produced by the photolysis of carbon dioxide and water vapor by ultraviolet radiation. Lastly, we have the third atmosphere. Around 2.5 million years ago, the amount of oxygen available in the atmosphere started to rise due to the evolution of photosynthetic organisms that produced oxygen. So now, you can see here, our atmosphere is mostly nitrogen and oxygen. The atmosphere is predominantly a mixture of nitrogen and oxygen, with smaller amounts of carbon dioxide, argon, water vapor, and other trace gases. The atmosphere is a dynamic system with inputs, outputs, flows, and storages. Here is a systems diagram of the atmosphere. You can notice inputs of both energy and matter. Stop the movie and study the slide, looking for inputs and outputs of energy and matter. With regard to energy, the incoming solar radiation passes through the atmosphere and is absorbed by Earth or water vapor or other gases. Or the incoming solar radiation is reflected by Earth's surface or by the clouds. This long-wave radiation of the reflection can be absorbed by clouds, water vapor, and other gases. It can also be emitted by clouds, water vapor, and other gases. Again, this emphasizes the inputs and outputs of energy in the atmosphere as a system. Significant idea number 2, the behavior, structure, and composition of the atmosphere influence variations in all ecosystems. In fact, every single layer of Earth's atmosphere plays a crucial role in supporting life on the planet. When we are talking about the atmosphere, what are we even talking about? The atmosphere is the mass of air surrounding the Earth. This mass of air, extending over a vertical distance of about 10,000 kilometers, is basically divided into 5 zones or layers. Starting from the surface of the Earth, these layers are the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. Each of these layers plays a crucial role in making the Earth the only planet with life. Without this protective covering, the Earth would have been as dead as the other planets in the universe. So, are there differences between these layers of the atmosphere? In fact, temperature varies between atmospheric zones. As you can see, there is a decrease with altitude in temperature in the troposphere. There's an increase or a rise of temperature with altitude in the stratosphere. And in the mesosphere, temperature declines with altitude. And in the thermosphere, temperature rises with the altitude. There are pauses in between each of the layers of the atmosphere. These boundaries are pauses. Notice, however, that if we're looking at pressure, pressure decreases with increasing altitude all the way up through all layers of the atmosphere. You can think of atmospheric pressure in the same way you would think of ocean pressure. The deeper you dive, the greater the pressure because more water is pushing down on you. At sea level, you have the weight of all the air above pushing down on you. Thus, as you increase your altitude, right, the air gets thinner and there is less air pushing down on you, resulting in lower atmospheric pressure at higher altitude. Significant idea number 2, the behavior, structure, and composition of the atmosphere influence variations in all ecosystems. This diagram illustrates the connection between the various cycles of Earth and the atmosphere. So, of course, there are cause and effect relationships between the atmosphere and the ecosystems on Earth. As this diagram shows, the amount of insolation received at different latitudes varies considerably, dependent on how close the sun is to specific points on Earth. Therefore, the tropical latitudes have a net gain in solar energy, or a positive heat balance, and a net loss at the poles, a negative energy balance. Atmospheric circulation results in a horizontal and vertical heat energy transfer occurring within the atmosphere in order to balance out the energy through atmospheric circulation. If there was no atmospheric circulation, the poles would get increasingly colder and the tropics hotter and hotter. The atmospheric heat budget, or global heat budget, is the balance between incoming solar radiation, insolation, and outgoing terrestrial radiation. The energy budget is affected by the structure and composition of the atmosphere. Greenhouse gases in the atmosphere play an important role in keeping Earth warm. The greenhouse effect, short wavelengths, solar energy arrives at Earth. Long infrared light is radiated back into the atmosphere. Greenhouse gases, the composition of the atmosphere, absorb the long wavelengths. Trapping these infrared wavelengths is the process that keeps Earth warm, with an average global temperature of 15 degrees Celsius. Remember, the greenhouse effect is natural and necessary phenomenon for maintaining suitable temperatures for living systems. The gases responsible for the greenhouse effect don't make up a large percentage of the atmosphere. In fact, they make up less than 1% of the atmospheric gas volume. Naturally occurring greenhouse gases include carbon dioxide, water vapor, methane, and nitrous oxide. Most clouds in the troposphere play an important role in the albedo effect of the planet. Clouds reflect sunlight, contributing, right here we see them reflecting sunlight, contributing to the cooling effect of albedo. But keep in mind, clouds also contribute to warming at the same time because they consist of condensed water vapor, which retains heat. Most reactions connected to living systems occur in the innermost layers of the atmosphere, which are the troposphere, 0 to 10 kilometers above the Earth, and the stratosphere, 10 to 50 kilometers above Earth. The troposphere is the lowest part of the atmosphere. It is the part in which we live. The troposphere contains water vapor in the form of clouds, rain, and snow. And most weather phenomena take place in the troposphere. The second layer of the stratosphere is where the ozone layer is located. And because the ozone absorbs UV light from the sun, protecting us from these harmful rays, it is the reason why temperature rises in this layer of the atmosphere with altitude. The next layer, the mesosphere, is difficult to study because it's difficult to keep satellites in orbit there. However, the mesosphere is an important part of Earth's protection because it burns up most meteors and asteroids before they are able to reach Earth's surface. The thermosphere is the outermost layer of the atmosphere. It is the largest layer. And the aurora borealis, or the northern lights, take place here. Human activities impact the atmosphere composition through altering inputs and outputs of the system. Changes in the concentration of the atmospheric gases, such as ozone, carbon dioxide, and water vapor, have significant effects on ecosystems. Stop the movie and study this slide just to gain an appreciation of the inputs and outputs that affect the atmosphere and, of course, resulting in impacts on the ecosystems of Earth. One such change is in the concentration of atmospheric gases that is increased due to human activities, resulting in the enhanced greenhouse effect. Greenhouse gases are those atmospheric gases that absorb infrared radiation, causing global temperatures to be higher than they otherwise would be. The added greenhouse gases trap more long wavelengths, the infrared, than is normal, causing an increase in average temperatures. Levels of greenhouse gases are increasing due to human activities. The added gases have caused an enhanced greenhouse effect, more re-radiated heat, more heat trapped, therefore warmer temperatures. Here is a list of 6 greenhouse gases. Memorize the first 5. All of these gases absorb long wavelengths, the infrared wavelengths radiated by Earth. They re-radiate the energy back to Earth, contributing to the warming of Earth. Make sure you know the sources of these different greenhouse gases. Elevated levels of carbon dioxide in the atmosphere come from the human activities of fossil fuel combustion and deforestation. Enhanced methane levels come from the anaerobic decomposition of organic matter in rice paddy fields and the guts of cattle. Enhanced dinitrogen oxide comes from the use of fertilizers in agriculture. Chlorofluorocarbons, or CFCs, are released into the atmosphere from the use of refrigeration, air conditioning, aerosols, and solvents. Smog contributes to tropospheric ozone. In topic 6.3, we talk about smog as an air pollutant. Keep in mind, it is also a greenhouse gas. Keep the different roles, pollutant versus greenhouse gas, sorted in your mind. Again, the focus of it as a pollutant is in topic 6.3. Human activities resulting in air pollution cause a depletion of the ozone layer, another change in the composition of the atmosphere. This will be discussed in greater detail in topic 6.2, stratospheric ozone. Here is a summary of this subtopic, the introduction to the atmosphere. This ends the movie for IBESS topic 6.1, Introduction to the Atmosphere, under the main topic of IBESS topic 6, Atmospheric Systems and Society. The slides were created by me, Dr. Nina Markham. Image sources are indicated with a URL under the image. If all images on a slide are from the same source, the source is simply cited at the bottom of the slide. Another resource for you is your IBESS textbook, whether in hardback form or online, such as Cognity. Thank you for listening.